Hello, everyone, and welcome to Sum, Count, and Beyond, the Spreadsheet Source, Session 12. Today, we will be learning about different types of charts and graphs. In the About section and in the banner image of our channel, you will see a link to a Google Drive folder that has spreadsheets from all of the sessions. Each file will have at least 2 tabs, Try It Yourself, and Solution. We would encourage you to have your own sheet open or download the file and follow along as we go through our examples together. Before we jump in, don't forget to give us a like and subscribe to our channel. If you think we missed something or want to see a certain topic we haven't covered yet, leave us a note in the comment section. Let's get to it. Today we are going to cover the basics of 4 different types of graphs: pie charts, bar graphs, line graphs, and scatter charts. Charts and graphs are extremely useful when you want to bring your data to life. A properly used graph or chart can be a great way to convey a large amount of data and what it means quickly. When creating graphs and charts, the 2 things I always try to think about are 1. What story am I trying to tell? And 2. What is the best way to tell it? We will be using smaller data sets to work on the concepts, but the same principles can be applied to any size data set you have. In general, I view the different graphs as follows. A pie chart or pie graph shows the parts of a whole. A bar graph is used to compare different groups. A line graph is used to show time series data. A stacked bar chart is for comparing groups over time or comparing parts of a whole. And then a scatter chart is showing a variety of random data points to see if there is a trend. So let's say, for example, you are doing a project on the Great Lakes and want to show the distribution of water by volume between the different lakes. So going back to our 2 questions, what is the story and what is the best way to tell it? We are trying to show the volume of water in each of the lakes, and we want to show how the individual lakes contribute to the whole. Any guesses on the best way to tell the story? For me, there are 2 that come to mind, a bar graph and a pie chart. Let's take a look at both and try to figure out which one makes more sense. Cells A7 through B12 have the Great Lakes water volume broken out by lake. So go ahead and highlight from A7 to B12, and then you can go up to the ribbon here, insert, and then right here are the different charts and graphs you can put in. So you'll see there's this recommended charts. So if we hover over that, it shows us a couple different options. So first, let's go ahead and put in a bar graph. And then we're going to go back. We're going to highlight our data again. We're going to go back. We're going to go to Insert. We're going to go ahead and do a pie graph. So of these 2 options, which one do you think looks better? So in my opinion, I think that the pie chart looks better, but let's start with the bar graph and we'll look at the differences between the 2. So the bar graph does a really nice job of showing the different volumes. So you can see Superior is obviously the largest, Erie is obviously the smallest, but it takes a little bit of effort to figure out how the parts add up to the whole total volume of the Great Lakes. So if we go ahead and look at the pie chart now, what we can see is that not only do we get an idea for the volume within each lake, but also we see how the parts contribute to the whole. So we can see here that Lake Superior is over half the volume of the total Great Lakes combined. Now if we flip back to the bar here, we know that Superior is pretty big, but we don't know kind of the scale until we look at how it contributes to the whole. So then within here, let's pretty it up a little bit. So if you right click, we can go ahead and add some labels in there. And you'll see that the labels in this case are the volumes that are in column B over here. Now if we go in, we select the labels, we do another right click, we'll go down here to Format Data Labels. We have a couple different options we can put in. So let's say, for example, instead of value, you wanted to show the percentage. You could go ahead and do that, and all of a sudden we see Lake Superior is 53% of the total volume. And then you can also do value as well. So you can do value and percentage to show that. And with the bar chart, you can obviously do the same thing. Add data labels in there as well. So keeping with our Great Lakes example, let's give the line graph a try. So the line graph shows us changes over time. So going back to our two questions, what is the story and what is the best way to tell it? What we want to show is the volume of water in each of the Great Lakes, and we want to show how that water volume has changed over time. Any guesses on the best way to tell the story? For me, there are two that come to mind, a bar chart and, as I mentioned earlier, a line graph. Let's take a look at both and see which one makes sense. So A21 through G26 have a time series showing the change in volume for each of the Great Lakes. You will see that column G has the same data as we have above in column B. And because it's highlighted in, or font color is green rather, you know that it's a reference to a different cell. So column G is actuals, columns B through F are just made up numbers so that we can see some variation over time. So let's highlight from A21 through G26. Then we're going to go back up into our ribbon here. We're going to insert, and instead of doing recommended this time, let's go over here to the bar graph icon, and we're going to insert a clustered bar graph. And then we're also going to click out and insert, again, back to the ribbon. I'm going to go ahead and insert a line graph as well. So let's slide this off to the side for now. Actually, pop back over here. So, which of these two do you think does a better job of showing the change in water volume over time? So personally, I think that both of these are pretty good options. In my opinion, the clustered column is a little bit harder to follow if we're just looking at what the change is over time. But I still think it does a good job of getting the point across. And again, we also get an idea for volume, and it's really quickly and easily able to point out, which is the largest, which is the smallest, and then how the fluctuations have occurred. But with our line graph here, I think it's just a little bit cleaner. We can really clearly see and follow each of the different lakes. So we see that Superior is this light blue color, and we can really quickly and easily track it over time. And the same thing for the other lakes as well. So if the goal is purely to show what does the time series look like and what's the change over time, I think we're better off going with a line graph in this case. So we'll slide that over. And if we wanted to put a title in, we could just put a title, double click that, water volume over time. And we can do the same one here. We can do Great Lakes water volume over time. Okay, so we're going to use our Great Lakes for one more example, and that is the stacked bar chart. So I like to think of the stacked bar chart as a combination of a pie chart and a line graph. The stacked bar will allow you to view the change over time and do it both at the individual and aggregate levels. Once again, the story you want to tell is how much the water volume of the Great Lakes has changed over time and how the volume of the lakes has changed over time as well. So if we go ahead and we select A37 through G42, and then we go up to insert in the ribbon, the stacked bar chart is right here. There's your stacked column. And so this is what I was getting at earlier, where it kind of has this dual purpose. So when we look, we can see the change in total volume over time as represented by the full height of each bar. But then within this, we can also see how the levels change over time. So we can see that over time, this is what Superior is doing, this is what Huron is doing, and we can see how the fluctuations contribute to the parts of the whole. So if we look at 1961 and 1971, Ontario was a decent portion, but not huge. And then for whatever reason, by the time we hit 1981, it looks like the volume almost doubles from prior periods. And you can really see that jump out, whereas we didn't necessarily see that in any of our earlier graphs. So now if we think about this specifically, if we were trying to tell this same story, we could have used this stacked bar, or we would have had to use a line graph and 5 different pie charts, one for each year. Okay, finally we're going to go to the XY scatter graph, and the purpose of the XY scatter is to view the relationship between two variables. So A53 and C65 is a sample data set showing the average monthly temperature throughout the year and the number of Amazon purchases in that month. So if we select from B54 down to C65, and then we'll go up to the ribbon here, and we'll go to the XY scatter icon. Go ahead and insert the scatter. So this is what our XY scatter looks like. And so what you should see is 12 dots moving generally from the lower left to the upper right, which means that there is a positive correlation between temperature and Amazon orders. An important call out with the XY scatter is that correlation does not equal causation. This graph is not saying that nicer weather makes me order more stuff from Amazon. It merely shows that as the temperature creeps higher, so do the number of Amazon orders that I place. So before closing out for today, let's try 2 more things. So first, go ahead and go up to the ribbon, and we're going to click this Chart Design tab. We're going to go over to the left, and we're going to add a chart element. We're going to go down to Trend Line, and then select a linear trend line. And so now we see this dotted line is just showing the trend. So it's trying to fit the data and put it on a single line. And if we go ahead, we select our trend line and we right click. If we format the trend line and we scroll down, we can also put the equation on the chart, and we can display the R² value. And those have both dropped in right there. And so the equation can give you an estimate of Amazon orders given a temperature based on the observed data values. And the R² value will tell you how well the regression line fits the observed data values. And going back to statistics, regression, we can go from 0 to 1 for the R² value. So well done, everyone. You just learned about some of the different types of charts and graphs available in Excel and some ideas on how and when they can best be used. Whenever you are trying to use graphs to visualize data, always remember the 2 key questions. What story am I trying to tell, and what is the best way to tell it? So to sum everything up, graphs are a great way to visualize your Excel data and quickly get a point across. You can count on this session to help you understand how to insert graphs and some ideas on how different types of graphs can help you tell different stories. And let's keep taking your spreadsheet knowledge beyond what you thought was possible.